All right, we're in section 3.1 where we are going to solve one-step equations. Chapter 3 gets into where we get to solve linear equations. The first portion of this is being able to take a variable and put it by itself. So in order to do that, we have to kind of use what is called inverse operations, where we take two operations that do each other. So uh, if we have addition in a problem, you're going to subtract both sides to get rid of that said value. If you have a multiplication on one side, you're going to use division to get rid of those values also. So the main goal in this sequence is to be able to use equivalent equations. So equivalent equations is basically saying it's the equations with the same value. So if you're going to do one thing to one side, whether it's addition, subtraction, multiplication, or division, you're going to do that to the other side. Okay, so the terms for these items are as followed. You have the addition property of inequality. It's where you're adding the same number to each side of an equation that produces an equivalent equation. So if you're going to add both sides, so say like I have 5, say I have 5 equals 5, all right? So if I'm going to add both sides to 4, it's going to be 9 equals 9, still the same. Okay, same thing for subtraction. So say I had 3 equals 3, and I said I was going to subtract 1 to both sides, I get 2 equals 2. Multiplication property, same, um, same idea, where I say I have 7 equals 7. I multiply 3 to both sides, I get 21 equals 21. And then finally, the division property of equality says we're going to divide the values. So let's say I had 15 equals 15, and I said I was going to divide everything by 5. That gives me 3 equals 3. So as long as I do the same things to both sides, you're still going to have an equivalent equation. Uh, Depending on the circumstances. So you're going to use those different properties to kind of help you solve equations for variables. So looking at the first one, I have x plus 7 equals 4. In order for me to get rid of 7 on the left-hand side, I'm going to subtract 7 to both sides. So that's where the inverse operation comes from. That gives me 0, so all I have left over is x, and then 4 minus 7 is a negative 3. Okay, looking at the next example to my right, I have x minus 12 equals 3. All right, so if it's a subtraction, that means now I'm going to use addition to get rid of it on the left-hand side. So I'm going to add 12 to both sides. So that gets rid of the 12 over here, so I have x, and then 3 plus 12 gives me 15. Okay, looking on the other two examples below that, first one I have y plus 7 equals 10, so I'm going to subtract 7 to both sides, kind of like what I did in the example above. So now I have y left over on the left hand side, and 10 minus 7 is 3. Finally, q minus 11 equals a negative 5. You add 11 to both sides, so it leaves me with q, and negative 5 plus 11 gives us a positive 6. Okay. So sometimes you're going to have one-step equations where you're going to deal with addition or subtraction. Now here are situations where you're going to use either multiplication or division. So if you look at the 4 examples there on the screen, you notice that you are multiplying a value to the variable. So it's negative 6 times x. It's 4 times x. It's negative 5 times y. It's 6 times w. So I'm multiplying all of those values. So since I'm multiplying, in order for me to do the inverse operation, I have to divide in order to get the variable by itself. So if it's multiplication, that means I'm going to divide, which makes this 1. So now I just have x on the left-hand side, and 48 divided by A negative 6 is a negative 8. I divide over here. So that leaves me with x, and then 36 divided by 4 is a positive 9. I look at the bottom and I have negative 65 equals negative 5y. So that means I have to divide negative 5 to both sides. So that means I get y equals positive 13 because negative divided by negative is positive. And then finally, I have 6w equals negative 54, so I'm going to divide everything by positive 6. W here is going to equal a negative 9. Now, the examples over here, if you notice with the variable, there's division that occurs. So I have x divided by 4 equals 5. I got negative 2x divided by 7 equals 4. I got negative 8 equals negative 4v divided by 5, and 2p divided by 3 equals 14. So now here's the situation where you're going to use multiplication. So in this case, I'm going to multiply by 4. Well, when I multiply by 4, those cancel, so now I get x, but I must multiply by 4 over here as well to make it equivalent equations. So 5 times 4 is 20. Okay? The other three examples have a unique situation where you are going to multiply, but when you multiply, you're going to multiply by the reciprocal. And since I have negative 2 sevenths, the reciprocal of negative 2 sevenths is negative 7 over 2. So that allows me to cancel both of those values. So I just get 1 on that side. So 1 times x is just x. And then I have to multiply by negative 7 halves over here. If I multiply it across, I get negative 14 over 2. Negative 14 divided by 2 is, in fact, a negative 7. Looking at the example on the bottom, left corner, that means I'm going to multiply both sides by negative 5 over 4. So I'm going to do that over here as well. Cross out, cross out. So I have v over here. And then when I multiply this across, I get, what, 40? Let me erase that. Let's try that again. So now I get positive 40 divided by 4. Positive 40 divided by 4 equals, what, 10. And then finally, 2p over 3 equals 14. The reciprocal of this is 3 over 2. Cross out, cross out. I'm left with the value of p. 14 times 3 gives me 42 over 2. 42 divided by 2 is 21. And that is being able to solve one-step equations. Hope this helps. Until next time.